Okay, good evening everybody. Well, there's nobody here in the stream yet. Good evening anyway to anybody watching this after I've recorded the video. It's the evening AquaStax hour on Tuesday, December the 20th at 8 PM UK time, or just about 2 minutes to 8 PM. So, I've had a bit of a long weekend and a long day today, and there's a plane going over as well. I've been doing all of the filing needed for a tax return. And the tax return itself will be really simple tomorrow. Only takes an hour or so. But the actual filing in our house before you do the tax return takes a long time. So my brain is pretty frazzled. Had a long weekend. Anyway, let's see where we were last week. I have not looked at this project for a week, and it looks like I'm exactly where we left off. So let's fire up the gulp task. Check I'm not muted. Yeah. I've got my microphone on my face today, so the mute button I was using earlier, just for a quick test. And Chrome, isn't it? That's what we want. Can't even remember how I'm going to test the game. Chrome, here we are. AquaStax. So last week, Thursday afternoon, I believe it was, got quite a bit done actually. I got to drawing borders and regions around the blocks, figuring out where they were, so they hit the left and right hand edges of the grid. Move right. I think it lands as well. Does it land properly? Yes, it lands nicely. If I rotate it, it stops rotating after a point. I think that was probably what I was going to sort out today first. There was definitely some glitches with the rotation. I don't like the fact that it prevents you from rotating if the rotation, as it's coded in the game code, would put the block outside of the grid in a collision scenario. So I think like now. Now I'm pressing the up key and no rotation is occurring, which is rather annoying. You definitely don't want that kind of lack of response when you're pressing a key. Can I move it around? No, I can't move it now. It's landed because it's also colliding at every frame or every game tick. So let's continue to just briefly remind myself what I did. I think my grid had some code which, yes, I left it commented out and it renders tile boundaries. Let's just remind myself of what I did here. What was corners? Looks like I'm drawing the corners of the block in some, or drawing a whole block in some way. Let's just see what happens if I do this. So yeah, so we've got the left hand boundary, the bottom boundary in yellow, that shifts to the middle there at that point. The right hand boundary in the sort of teal color, maybe cyan. Yes. And definitely the left and right and the landing on the ground is okay, but the rotation is now in certain scenarios causing the block to be stuck. And that's probably when the game code, let's see, so we've got this update function and we dropped the block quickly, so that was another thing that was going wrong as well actually. The block stops dropping as the collision occurs. It's probably to do with this bit of moving the block, and the self.move block doesn't happen if it's in a collision scenario. Let me just have a quick reminder of myself as to what was going on there, because it kind of feels wrong where you can scoot the block down quickly and then it stops right at the end and doesn't land until I let go. Oh, hi, Reghale, good to see you. First person this evening, I was just reminding myself of what I ended up doing at the end of last stream, and it was to do with the block collision, and I'd implemented some boundary checking on the blocks. So as you can see, there's a couple of different lines that are drawn for debugging purposes to display the left and the right and the bottom boundaries. And that means that my block doesn't go outside the boundaries of the grid when I move it left and right. But it does also mean that at certain points, I can't rotate the block. If I press up now, it won't rotate because there's a check in the code to see if after a rotate, it would be in a collision scenario. And unfortunately, in that case, it is. So we need a bit of code to move it away from the collision point. And also, there's another nasty little glitch where you can drop the block down really fast, but it stops at the bottom until I let go of the key. Then it lands that last few 2 or 3 pixels. There we go. You can see it a bit better there. So I'm going to sort out that as well, I hope. Right, dive straight back into it. As I was saying earlier, I had a long weekend and a busy day today, so brain's a bit fried. So it might take me a few moments to get into speed, or get up to speed. Fast drop. So let's focus on the fast drop bit first and see what's going on there. So what happens if I don't actually do a fast drop? If I just let a block settle by itself? So that's perfectly fine. It settles. The actual collision functions still occur manually. So I hit space, and then a new block will land or will arrive. But it's while I'm holding down the key, it gets stuck at that point, and then I have to let go. So let's see if we can figure that out. So it's definitely to do with the drop the block down quickly. Self.fast drop equals true. And down here, if we're doing fast drop, we're multiplying dy by 20, so we're actually moving it at a much faster rate. And then we're coming in and doing move block by, of course, it's going to moving the block 20 times normal distance per game update means that it's going to stop at 20 times normal movement distance away from the block, because at that point dy times 20, so the position plus dy times 20 would actually put the block into collision. So how do I fix that? I suppose we can do an attempt to collide the block up here in the fast drop scenario. So let's do this. So the collide block only returns a value if the collision is, let's see what it does. It returns true if there's no collision and false if there is a collision, or the other way around. I can't even remember. Let's see. I should have commented this really, yeah. See. So test collide block with grid bounds returns true if collision occurs, false otherwise. I expect it's going to be the same on these ones, isn't it? Collide block with grid data. Let's comment these before I forget. So this is colliding the block with the blocks that are already in the grid. Test if the given block at a new position will collide with tiles blocks already in the grid. Oh, hi Live Coding TV, good to see it. Hope it's all going well. Let's see. Then let's just make sure it does return true if a collision occurs. So we're testing indexes, we're looking at what's in the grid and returning true. Okay. And then surely collide block, which calls both of these, will be the same. But I'll comment each of these just so I don't forget. Or at least I will forget, but I'll be reminded fairly easily. Oh, thank you very much. Merry Christmas to you too. Christmas started early for me this year. I went to my cousin's house for a big family get-together this weekend, and he's got 3 kids, so they were running around, running us all ragged. Though one of the young lads, Elijah his name is, was showing me some programming he'd done in Scratch, which was really awesome. Actually been programming a game in Scratch, the sort of I say programming language for children, but it's actually a fully blown programming language. You can write some pretty sophisticated things in Scratch. And he was interested in how to move on to Python. So I showed him how to use Python and Pygame, which is the game library for Python. And he was picking it up really fast for a 12-year-old lad. Very impressive. Anyway, back to JavaScript, and I was testing collide block. And definitely is going to return true if a collision occurs. So any of these are, usually with collision testing, you're going to bail out quickly if you know that the collision has occurred. So we return true, and then if it gets all the way to the bottom, there's no collision. So we're going to return false. Is the game completed now? Oh no, long way to go yet. Or did you mean my my cousin's son's game? But my game is still only, I would guess maybe 10% in, probably less than 10, somewhere in single figures still. If you compare the state of my remake, which is what I'm doing now, with the game that I made 10 years ago. But we do at least have some blocks falling down. Let's see. So collide block, return true, and we're going to look inside game, I believe. Yeah. So if fast drop dy times equal 20, let's do. We have to actually do a test again, don't we? Test self.block and p. P is the position. I'm going to have to do this. I keep continually finding myself looking at code, copying and pasting, and I'm going to have to refactor that in the future. So definitely going to have to refactor this in the future. If, let's see, if fast drop, all we really want to do is, if it's not colliding, then we do the multiply by 20. Otherwise, we leave it by we leave dy as it is. And in fact, p self.block.get position. We are not. Oh, we actually no. We're not updating the block at this point. We're only updating the block down inside set position here. And what I could do is, let's do this, current block position, and we're going to update it there. Ooh, actually, it's not current block position. It's going to be. I know what we can do. We can do new block position. Dot x plus dx and dot y plus dy, and then we'll pass new block position into the collision test function. So this is specifically testing a new block position if we're doing the fast drop, and if it doesn't collide, then we're okay with the dy times equal 20. In fact, I need to do it here, don't I? I need to do dy times equal 20 there. Test the block. If it collides, we just do, let's see, fast dy equals dy times 20. Fast dy. So dy equals fast dy. So we only set our dy value, delta y, in the event that the block doesn't collide. And then down here, we're effectively going to do something similar again. And I could pass in current block position, couldn't I? To save getting it again. Or I can just, I'm just going to do this. Make it slightly more verbose. There we go. Right, let's try this. Okay, so fast drop. Ooh. Oh no, it crashes. Probably got some mistaken code. dx is not defined. Where's that? Oh, it's up here. So actually we want dy. I only defined it a bit further down in the code, didn't I? dx equals self.dx times aq.block size. So that's the actual distance in pixels or in points that we're going to move each time. So dx, dy, we can put dx in there. Right, let's try again. Nope, still not working. Let's see. So fast drop. Collision. After all the comments, I still get the code wrong. Collide block is false when no collision occurs. So we actually want that there, don't we? When no collision occurs, we keep the fast dy going. There we go. And it stops, but it slows down at the last moment, which is actually fine. I remember my original game doing that, and because you can't fast. I mean, I could actually snap it into place, or it could slow down. I'll leave it at slowing down for now, but it doesn't actually stop in mid-air. Now it sits on the bottom. There, that's better. So that goes nice and slow when it comes to nearing the block. Just out of curiosity, let's see what it looks like when I do that. Yeah, might be worth a snap, but lots more code will come in the future when blocks slide over each other. So I'll not worry too much about that now. There we go, right. So that's that bit sorted. And slightly more verbose code. I'm just going to comment this. Pixel. I say pixels. I'm going to confuse pixels and points all over the place because it's not actual pixels. It's pixels multiplied by the scale of the game screen, so it can be smaller or bigger. But it's always going to be referring to the. I think it was whatever we set our original design resolution size at, width and height. See, it's so long since I did this, I can't even remember what I defined the game screen to be as. 1920 by 1080, so I used an HD screen resolution. So all of these internal points aren't actually pixels if the game isn't at full screen. But if the game is running at full screen, then they are actual pixels. But so I'll just leave it as points. The point difference to move the block in one game update. I'll put pixels in brackets just because so one thinks in pixels all the time. Right, so we've got drop the block quickly, move left and right, keyboard repeat rate, rotate the block. So now the next thing I want to sort out is why I can't rotate the block in certain scenarios. So all the time the block is dropping by itself, I can hit the up button and it will rotate nicely. But if it gets to a point where the rotation would put it into a collision, which is like now, so if it moved, normally what happens is it kind of shifts slightly to the left, or it rotates around the narrow point of the block. So what would happen was, if it rotates around the narrow point, at this position here, it puts the larger bit of the block outside the grid, and the collision function will be returning true. So it won't let me do it, because this bit of code here says only set the new rotation if we don't have a collision. But I don't want that. What I want is to still allow the rotation, but actually shift the block back over to the right, so that the block isn't colliding anymore. Now this is going to take quite a bit of interesting code, and I suspect if I write it now, it'll go wrong at various points in the future. But I think it's worth trying to at least put something in place so that the block handling or the block falling is working as I intend it. And then when it goes wrong later, due to things being in the grid or whatever, then we'll figure that out. It works the same on the right-hand side as well. I can't rotate that, but I can rotate that because it shifts around to the right. And again, but now it's stuck. I can't rotate. So let's see what I can do. I mean, the obvious thing here is to test if you're off the left-hand side of the grid, push it to the right by one grid cell, and if you're off the right, push it to the left and try again. And it may be the case that you have to push it 2 or more grid cells. And the same with the bottom as well. When it lands on the bottom, although actually I don't want anything to happen when it hits the bottom, so I won't worry too much about that, I don't think. Or else you'd be able to rotate it and it would basically hover off of the bottom of the screen, or off the base indefinitely. Let's just see about left and right. Rotate the block through 90 degrees. What I want is to get the collide block with bounds function to return something, some indicator of how far out the collision is, or how many grid cells to the left or right it is. So let's see what we can do. Set grid index positions for block collision. And at the moment, oh, this is grid data. I'm looking at, this is what I want to look at. So we do know that we actually return we have boundaries, don't we? So it's using the get tile bounds. I wonder if it's really as simple as looping over, pulling it back left or right by one grid cell until it's no longer colliding. Because that would work on the left and right edges of the grid. And like I said, I'm not going to worry about the bottom at the moment. So let's do self.collide block, potential position and rotation. Okay. So we want to know that we're not on the bottom of the actually, we'll worry about that afterwards. Let's do this. Yeah, we don't know if it's colliding left or right, do we? Is there a way to pass that data back? I mean, it knows here, doesn't it? So maybe I switch my collision function from a Boolean to simply being an integer of some kind that will let me determine different things about the collision. Yeah, let's do that. So, having commented all this, I'm now going to change it. Test if the given block at the new position will collide with the grid boundary, the grid left or right boundaries. Let's return 0 if 0 for no collision. Let's see, I guess -1 and 1 makes sense for left and right. -1 for left boundary, -2 for right boundary. So this is straightforward. Return 0, colliding with the left boundary, -1. Actually, positive. And do +1, so -1 for left boundary, +1 for right boundary. +1 for right boundary. Ooh, and we do know when it hits the bottom, so 2 for bottom. Let's do that for now. Some arbitrary number. And down in here, so 0 is still going to be false. Actually, this will still kind of work, won't it? Because you can test against 0, negative and positive numbers. But let's see, we want collide with grid data. I'm just going to put some arbitrary numbers in here. True if the collision occurs, so let's see, 0 for no collision. And let's have, so 1 for a left boundary collision, -1 for a right boundary, 2 for a bottom boundary. Ooh. So it's a game grid baseline, and 99 for a collision with an existing block. So collide block with grid bounds. If bound collision does not equal 0, return it. Collide block with grid data. At the moment, I'm going to change this one because I'm pretty sure that I'm going to want to do a whole load of different things in the grid collision with block data a bit later on, returning different values for different types of collisions and possibly where the blocks are going to slide as well. So let's change this now. Return 0 for no collision and 99 for a collision. Other numbers will mean something else in the future. Oh, there it is. I knew I had 2 typos there. So return 0. Now this is return 99 or 0. And does not equal 0. Return it. Else return 0 for no collision. Right. So now let's do right. So if while the collision is -1 or 1, we want to actually adjust potential new rotation and position dot position. We want the x is going to plus equal. So here's where I should probably have done this the other way around. If it's a 1, that's a left boundary collision. We want to add the potential point by a grid. So if it's a 1, I've got to get my my geometry right. If it's 1, we know it's collided with the left, so we want to add it. If it's -1, we know it's collided with the right, so we want to subtract it. So all we want to do is add collision times by block size to the x or y position, sorry, the x position, and then rerun the collision calculation. Ooh, there. Elf.block. It's a Christmas reference for today. I still have one more stream before Christmas, so I'm going to be busy next week, so I'm going to have to not do any more streams, or not do any streams during the Christmas week. But I've got one on Thursday afternoon to do that. So that should, it's not collision, is it collision? No, it is. Yep, collision is just the number. And that will set new position and rotation. While, actually, what am I doing? I'm doing this, aren't I? Collide block. That's it. Let's put that there. And it's outside here that set new rotation and position, because after we come out of here, we're always going to not be in a collision situation, so we can just set it. Let's see what happens. Right. So normal rotation works. And can I do that? Nope, it crashes. Probably infinite loop time. Yeah, almost certainly going to be an infinite loop. Can I just break anywhere I like? Ooh, is Chrome not happy? Tight infinite loop like that is probably killed Chrome. No, it's still running, responding. Not got my sources going on here though. Let's just reload it. And before I do any actual breakpoints, let's put a break into game, isn't it? Here we are, just here. So let's rotate. So collision is 0. So in this case, oh yeah, no collision. It should just carry on and work, shouldn't it? Yes, so that was working fine. Ah, now it's letting me do it, actually. That's interesting. So that collision function is letting me do the collision because it's just doing it arbitrarily. It always assumes we're never going to be in a collision scenario, doesn't it? So if I do, it's here, we actually just want to do if collision is equal to 0, because it might be 99 or 2, I think, on the bottom position there. We do that. Now, what I should do is break inside that while loop so I don't have to keep doing it. Right. So collision is -1. So potential new rotation and position. Position X. So that's -50. Yes. Oh, that's interesting. I got this wrong, didn't I? So now it's going to be -100, which will still be a collision. Yeah. So it's just going to go off forever. So it's actually the other way around, isn't it? Did I say -1 as the left boundary? Yeah, yes. I said -1 was left boundary. Did I get the code wrong? So if position X equal plus bounds.left times block size is less than 0, return -1. That should be left boundary collision. And in this, when we first did it, it was left boundary collision. Ah, yeah, -1 is left boundary collision. But we want to increment the potential X value. So we want to do that. And if it's 1, then it's the right boundary. Then we want to subtract it. But that's going to get really confusing. So I'm going to change this. I'm going to have 1 for left boundary, -1 for right boundary. Make sure I update the other comments. 1 for left boundary. Ah, looks like I'd already confused myself by writing comments in 2 different ways. So that's what I'd written, but actually it was wrong. That's why I did that. Told you it'd been a long day. Right, so now, fingers crossed, it will work. Let's lose the breakpoint. Reload. Ooh, probably still in the infinite loop, aren't we? Right, so what happened before is there, it wouldn't rotate. If I move it to the left, rotate, it does, and it shifts slightly to the right. Perfect. And if I do it this way, yeah, I can rotate, and it shifts slightly to the right. Actually, it shifts it off of the, away from the edge. Oh no, it doesn't actually shift it away from the edge. It rotates it around, but because it's rotating around on its narrow point, the next rotation will move it, move the square block down below the triangle and it will be one away from the edge. So that's cool. So you can now rotate even if you're near the edge. I'll try that with a couple of different shaped blocks as well, just to make sure it's all working. And hit the bottom and it stops, that's fine. Because now we're getting a return of 2 on the collision test. So I can't rotate it once it hits the bottom. Oh, I can. I could rotate there, because the rotate wouldn't have caused a collision until it's now tilted over. I must do something about recognizing when the block is stopped, because at the moment I have to manually hit my space bar. So if I do that, yeah, because it's rotating around its point, I can actually flip it over by doing that. But now I can't go any further because it's rotating, and I'm not doing a push up from the bottom. Right, let's try a different block. Is that main? Oh, it's game, isn't it? Don't need main at the moment. Don't need project. Don't need that test node. All that. Come back in here. Right. I think some of these aren't going to make a difference because they're oddly shaped. Oh no, let's at least test they work. Yeah, I can rotate these around. Oh, and I can rotate really quickly as well. The key repeat must be quite... Oh no, it's not higher. It's just because it's rotating 90 degrees instantly. It's really fast. Might have to do something to slow that down at some point in the future. 2. Yeah, so this is rotating around its solid square point in the middle there. So at this point it's okay. At this, if I rotate it once more, it shifts itself to the right a little bit. And now I keep rotating and it's one cell away from the edge. Great. The other day I had a fancy block that was like a test one made up of wacky large sizes. I might make myself another one of those just to test an unusual shaped block. Make sure the rotation is all working properly. Let's just go back to a couple of other ones. 3. Oh, this one's not going to make any difference whatever happens. It's always just going to be one cell. I need to print out a little cheat sheet that reminds me which block is which. Ooh, deja vu. In fact, I'm sure I had a little cheat sheet printed out for me 10 years ago when I was developing this game first time round. In fact, I know I did. I might even still have it in a drawer somewhere. Pretty quiet tonight. Not too many people viewing. Good to see you're still around, Regal. Hope you haven't fallen asleep with all the Christmas cheer. Right. I suppose I could do the little one, the last one. This one's got an unusual configuration, sitting on the bottom of its cell. Yep, shifts around, shifts itself away, and it's all good. Let's just try it down the other side. Yeah. So if those little little lines and boxes weren't being drawn, then it would look pretty much like you could play the game. Land the blocks. Let's see where we are. Well, that's not bad for half an hour and a bit's work. I'm going to now see if I can get the collision to occur automatically without me having to press the space. So that's going to be interesting, because, or should I maybe take into account, there's 2 different ways of doing this. One is I could just make it so that when a block lands and the collision occurs, the next one starts falling, or I could expand on the collision routines a little bit so that the shapes fit together. That's probably a better thing to actually do to start with. So for example, if I land that there, that's okay because there's no collision occurring. But let's see that. Well, where's that going to land? That lands there. That's okay. Trying to find a block that's got an unusual shape to it. See what happens if I do that. Yeah, that's interesting. Now, why would that collide? It shouldn't do. It looks like it should fit over that, shouldn't it? So I think there's a large number of scenarios where blocks of different shapes, so triangles and squares, should be able to fit over each other. So these collision routines have to sort of take that into account. But they also have to do it when the block is sliding down, because it doesn't jump from one block to another. It moves sub-grid square distances in the vertical axis. So, for example, there might be a point where if I have the, let's see what we get now. Yes, perfect. I can drop that one down like that, and it won't collide until it gets right to the center point. Although actually now, where's it going to collide? Ah, yeah, it stops there, because it's, I think at the moment it's just colliding the 4 cells that define the falling block or tile. And if this was to shuffle down a little bit, it would collide with this. But it has to take into account the fact that that can move all the way down to almost the entire point there and still not collide. So that's quite interesting. Yeah, I'm going to do that first. First, I'll just have a sip of tea. Right, I use my mute key there because you don't want to hear me slurping tea. Okay, so I'm tempted, very tempted, to go and look at my old code to see how I did this, because I remember writing some geometry routines that actually collide triangles, and it was quite complicated. And I think I spent quite a bit of time figuring out how triangles collide, and I used one of my graphics. Have I still got my book on the shelf here? No, I haven't. But I used a graphics programming book, and I was really pleased with myself. And in the end, I seem to remember those routines were barely used. And in fact, they may even have been optimized away entirely by the end of the game. So I don't particularly want to go back and look at those. But it might be worth reminding myself how the kind of general structure of my collision function was. So let's dive into my old project here, have a quick look. So that was, we were looking at Cocos2d-JS last time. Hopefully I've got all I need to know out of that now. Let's have a look inside AquaStax.java. So, collide with world bounds. So this is very similar to my new function collide with grid bounds, I think I call it, but a little bit simpler, mainly due to the way I stored all the old data. It was very complicated. Test block collision, test block for general collision. Yeah, so this does collide with world bounds, collide with game grid. So collide with game grid is where it does all of the fancy stuff. And I've called that in my new code, I've called it collide with grid data. So getting all the boundaries, I've done boundary code, and then we have a loop, and rather than collide directly at the square position, simply collide a fraction of a block in the square currently occupied by the block. This should prevent the collision routine from returning. Ah, yes. So I remember now. My collision routines used to return a couple of different values. So where I've just put in -1 and +1 and 99, I actually had some values for axis and slope collision. That's right. Now I remember. And there was projecting out of grid. Yes, rings a bell. So, no, I've lost where I was. Can I jump back? No. Ah, here we go. Right. Collide with world bounds. Collide with game grid. So what did it do? Sideways? That was passed in. Collide square with game grid. So actually, we're looping over the blocks within the cells within a block, and each individual block. So it looks like each individual square block that's part of a falling tile or a falling block is collided with the game grid by itself, and then the collision information is ORed together, so it's building it all up. Okay. Oh, hi, thanks, Lock88. Good to see you. Let's see, what do we do? Get square block. Yep, that returns the block data. Collide square with game grid. So this is probably where all the work happens. Test an individual square of a block with the game grid. This could possibly result in up to 4 grid squares being tested against. Yes, of course, because blocks can overlap up to 4 squares. Let's see if wherever one of these is. Actually, no, it's only ever going to be 2. I think I wrote the code for the general case if it was shifted left and right by less than a full block's width. But actually it's only ever going to be 2 that's going to overlap. So there it's not overlapping any, but as it's halfway between blocks, it will be overlapping 2 blocks within the grid. Yeah, usually be only 2, I think. Returns the type of the collision and reports the response to the block. So that's whether or not it's shifting in or out. So what do? We use a function called collide objects, okay. And we're testing, do we have a platform? Well, platforms, a bit later on in the game we'll add platforms. Do you have a collision against an occupied block in the game grid? So what does collide objects do? Here's platform background collide objects. Collide 2 squares together, one moving from the falling block and one static within the grid. This method first does boundary box checking, and then if the 2 squares overlap, it further tests square square, square triangle, triangle square, and triangle triangle type collisions. Wow. So it does quite a lot of stuff. So what am I doing here? Object may be collided with this tile. Call the shape specific collision function. Right. Okay, so we've got square, collide square with triangle, collide triangle with square. So I did use these triangle collision routines. I bet they're pretty complicated. Handle a square colliding with a triangle. A lot of maths, yes. And axis aligned bounding boxes, AABBs. Wow, I'm gonna have to acquaint myself with how I did this. From what I remember, I definitely used the old Foley and Van Dam Principles and Practice of Computer Graphics book, which I've still got somewhere. I can't see it on my bookshelf at the moment, but it's there somewhere. Collide triangle with square. Oh, interesting. I wrote collide square with triangle and collide triangle with square. You'd think they'd be very similar. In fact, they do look very similar. That may well have been for performance reasons or laziness on my part. I expect somewhere down here there's a minus instead of a plus, and that's all there is to it. Anyway, and then there's collide triangle with triangle. So this one's even more complicated. Blimey. Uses some dot products. So these molfp commands, these are all fixed point maths functions because we had no floating point back in the old mobile phone days. So lots of fixed point mathematics. It's testing the dot product of vectors and seeing if one is less than the other. Okay. That's going to be quite complicated to redo. I'm sure there's a simpler way of doing that. What I'm going to do is pretty much ignore all of the low-level bits of that, but do something similar with the high-level, which is loop over each block within each grid cell within the falling block or the tile, and figure out which cells within the grid I need to test against to see if a collision has occurred. That's probably about all we'll get done today, if we even get that far. Then I can worry about the specifics of colliding triangles or squares if I need to a bit later on. Most cases are going to be square to square, but where you've got these points that are half triangles, then it could be triangle to triangle. But a lot of the times I suspect a special case will work in that they're only ever going to collide if the block is over halfway into the collision block that it's testing with, if it's triangle, because they're only ever going to hit points, they're going to hit the middle blocks, the middle of the triangles. So there's probably some fairly simple, straightforward optimizations to be done there. Anyway, let's go back to here. So in grid, just out of remember, what did I call it? Collide with game grid, and then we used collide square with game grid. So what we were doing was we were working out all the blocks within the grid. So it's collide block with grid data. So it's definitely this one I want to do. So indexes, get grid index positions for block collision. So this is what I'm doing. I'm working out the indexes of the grid that I want to test a block with. We do a bunch of those actually. So we're doing it all in one go. That's interesting. I could use this actually, rather than do one block at a time. We might as well do it this way, or one grid cell position at a time. We will do it one block at a time by using the array return from here. Let's see if it even works. What I might do is I might draw these grid indexes, and we'll see what that looks like as the block is falling. That way we can start visualizing the collision functions. Okay. I want to draw this function, don't I? So collide block with grid data. Let's set up some draw nodes for the purposes of collision testing. So we do a bunch of them already in the grid. The highlight pos we use, don't we? Grid highlight pos. And this is where we're drawing the rectangles. So I could use no, I'm going to make another one. I'm going to do node for collision testing. So grid collision squares. Grid collision squares is going to be a draw node. And what we're going to do is every time the dramatic pause, here we are, every time this function is called, I'm going to update those. I'm going to draw some squares at the positions and see what's going on. Right, so we want, in fact, let's split my editor in half so I can remember the draw recs. I probably want fill recs actually. Oh no, it is draw rec with a fill color, isn't it? Yeah, that's right. So we want to clear the current node, and then we want to do for var. I could do it down in here, indexes.length. Actually, no, I'll do it in a separate loop. Var n equals 0, and it's less than indexes.length plus plus. We want to work out the x and y of the position of the index. So how do we do that? Get grid index for block collision. Get grid index for point. We want to do get grid position for point. Here we go. Oh, there's this bit of code here. I could probably put this into a function, couldn't I? Get grid position for point. Get grid index for point. Get grid position for index. Get grid position for index. And we basically just want to do this, don't we? Except we don't need that bit. And down here, this is going to be return self.gateway position for index. So I can use get grid position for index, and that will return me an actual pixel XY position. Ooh. There we go, it's Alt. Shifting between a Mac and a PC, Control and Alt sometimes gets switched over. Anyway, right. Indexes N. And then we want to draw a rect. So we want self.grid collision squares draw rect. So it's P, and then cc.p p.x plus block size. We could use that, couldn't we? Save myself a little bit of typing. Y Coval48, good to see you. Block size there, plus block size, and p.y plus block size. And then we want, forget my draw, we want fill color. Let's have a fill color of some kind of red but slightly transparent. 128, there we go. And line width shouldn't matter actually, should it? So we should be able to do that. Let's see what happens. I have to add the node. Of course, nothing will happen until I add the node to the scene. There we go, right. So actually, that's good. They're the blocks that it's testing against, which is what I'm thinking is correct. However, one thing's for sure, and I know that that is when the block index isn't 0, sorry, when the block index is 0, I don't need to test anything against it, do I? So my function here, get grid index positions for block collision, if at this point, if tile, let's see, new index, indexes.push, I want to do if, so it's going to be if tile, and it's tile block data, I think, block underscore data, oh no, grid underscore data, tile grid underscore data, and that's indexed by rotation, isn't it? Yeah, so that's indexed by rot, and that's going to be indexed by y times grid size plus x, and just for good measure, I know I don't need to, but I like to just make it totally clear. I only need to care about the position if that point in the block is not 0. So if it doesn't equal 0, then we stick the index into our array of index positions to test for collision. So now, oh no, that didn't work. Did I miss a grid data is not defined? Ah, what did I do wrong? It's tile.grid data, isn't it? Tile.grid data. Right. There we go. So it's only testing those positions. So that's, yeah, that's kind of what I'd expect. But it's missing out the overlapping ones. It's only testing where the block is defined, and it's not caring about how it's moving. Okay, so I want to test this. So let's see about the overlaps here. So this was block pos rot. So if the position, bottom left index, so yeah, we're only working inside the grid. I need to know if the grid, if the block position is overlapping multiple cells like it is. So it's testing the first one, and that's shifting every time, but it also needs to test the one below it in this instance. These ones are almost working, but not quite. So let's see. So we know that the block, so this is the block position. I suppose there's nothing wrong with always testing the cells above and below on the assumption that most of the time it's always going to be moving between blocks, and only one frame in every second or every couple of seconds is going to actually be exactly aligned with the grid. So I might be able to get away with doing something like grid size. Yeah, so we're only looping over grid size, aren't we? Let's leave that out for a second. If I loop -1 and we do +1, then what I'm going to get is the cells above and below my falling block. A bit like that. So we've kind of gone a bit too far there, actually, haven't we? However, most of those blocks are going to bail out quickly when a collision occurs. Oh, sorry, bail out quickly when there is no cell data within that position. That's almost there. I'm trying to decide if that's what I actually want. Interestingly, it's going along the x-axis. I thought it was. Oh, of course, it's doing the blocks. It's doing the whole block again now, not just those positions. Can I take into account this? So, if x so block cell equals that. see what that does. Oh, nothing at all. I need an extra bracket somewhere probably. Oh, yeah. Left it commented out. That's doing the same thing as it was doing before, yeah, because it's now only testing the additional ones, but they'll bail out, won't they? So let's see. Maybe I do this, so I don't need that in there anymore. However, what I want to do is push additional indexes above and below the non-empty block. So let's try this. Let's do block size, boundary. I need grid width, don't I? Self.blocks wide, that's the one. I suppose if new index minus self.blocks wide is greater than equal to 0, we do that. And for now anyway, I'll assume they don't go over the top. Oh no, we should do the test. If, and the one above and below, if new index plus, is it self.grid data? Self.game grid. Self.game grid.length. Oops. Then we do that. So this will basically be the grid index above and below the one I'm testing, given the block that's falling. So that's new index plus self.blocks wide. So that, with any luck, doesn't work. Oh, it's indexes. Now we're going to get some duplication here. I can make the thing unique. See, that looks pretty much like what I want. Ooh, and I've just realized that as the block is dropping, there must be a way of optimizing that so that I don't need to take into account the one above it as it's falling like that. Although actually, it's probably more trouble than it's worth. I'm thinking about trying to get rid of those top two that aren't needed because the shape of this block is the way it is. But let's not worry about that. Let's try a different block shape and see what happens in game. Let's go back to something like 2, I think is... That's interesting. Yeah. Looks like it might have the rotation slightly wrong there because it's missing out a block there when it shouldn't be. Let's see what happens. Well, it's probably good enough for collision testing purposes, although I don't know why that's missing out a block. Gonna have to figure that one out. Maybe it's the rotation that's not right. It was in grid, isn't it? We're definitely using rotation here, aren't we? Block, position and rotation. Or have I got it upside down? Have I got my block cell? Oh, possibly. That's more like it. What I was thinking there is my blocks are defined bottom to top, and I was thinking it was top to bottom, but now the missing cell that it's not going to bother colliding with matches up with that falling cell position correctly. So what I'm visualizing here is the cells within the grid that I need to test for collision with cells in the falling block. As we go around, as the block is falling, those are the cells that matter. And in fact, they're slightly over the cells that matter, but I don't think that's going to cause a problem. Back in the day of mobile phones, I would have bothered with it and got it exactly correct, because any overdraw and over testing and things like that would have made it slower. But I don't think I'm going to hit anywhere near pushing 60 frames a second with a simple block dropping game. Now I've just remembered why I might be wanting to test the blocks to the side as well. Of course, if we're shifting left and right, oh no, the code will update the variables and then test for collision without rendering anything. So that's okay. Let's see some different blocks. Let's make sure that none of the blocks show the red shading outside of the actual. None of the blocks show a coloured area outside of the actual red shaded area, because that would be where it was not working. Yeah, so that's collisioning there basically, and it's colliding at the moment. I'm okay with that. I can fix that. I might get around to fixing that next week. Or no, what am I talking about next week? It's going to be Thursday afternoon. Looks like it's probably a good time to finish fairly soon. Had the hour and a bit longer. My next stream will be on Thursday afternoon at 3 p.m. UK time. Do join me. Do follow me on live coding if you want to get notified when that will be. No ratings today. If you want to give me a rating on the screen, get some fireworks, you can. I'll give myself a rating of 60, I think, because I've done pretty well today. I've fixed a couple of bugs, and I've now got a little bit of the way into finalizing my collision routines. So next week, hopefully, we'll do some more detailed collision stuff, and then we'll be able to get blocks landing on each other properly. Anything? Oh, I might as well commit this code to GitHub now while I'm at it. I always do that at the end of the stream. Let's kill that. Need to make sure that my gulp task is killed, or else Slick Edit won't shut down. Kill 1843. Okay, Slick Edit can shut down. Oh, actually, did I set up the other day? I might have set up version control in Slick Edit. Yes. So rather than using SmartGit, there are some options I could use here. Do I care? I don't want to commit the whole lot. Compare directory with Git. Compare workspace with Git. No, I don't want to do that yet. I'll probably end up spending hours. I'll just go back to using good old SmartGit. So just some changes today. Oh, actually, I'll put that back to 0 before I commit it. That's in game, isn't it? What changed? Oh yes, collision stuff. There we go. Enhanced collision testing. Commit and push. Excellent. Right. Thanks very much for watching. Much appreciated. I will maybe see you on Thursday afternoon at 3 p.m. UK time. If not, have a good Christmas. I won't be around next week. Lots of family Christmassy things to get going to do. And see you again soon. Thanks very much, everybody. Just use my OBS window here to go back to the old intro screen. Cheerio.